Today's job is to find out why we're getting slow heat up of hot water. I've already fixed the problem and found the cure. Viessmann 200. It's in a large house, 35 kilowatt boiler. It's about 20 kilowatts approximately for the heat load of the house. I've used close coupled T's for hydraulic separation. So down here's my close coupled T again. Flow from the boiler, deaeration, close coupled T, return to my boiler, and a flow setting gauge. If I just operate this for you, you can see at all times we've got pretty much the perfect flow rate through the boiler, irrelevant of what's going on in the system. Flow rate this side can vary. At the moment I've got a tiny flow rate through there, only about 12 litres, and if I operate some of the circuits we can see it increase. So if I turn on the hot water, I'll open the hot water valve on one of the cylinders. You can see the flow rate on the second part of the system's gone up. About 22 litres a minute. So you can see that coming on. Then if we turn on the heating circuit, it'll start to pull heat to the heating circuit. It might take a while, it's underfloor, so you won't see anything on this video. We'll see what happens. So as the flow changes on this side, this varies all the time. And the flow, the most important part is the flow on this side can be higher than the flow on this side. And of course we shouldn't exceed the maximum flow for this boiler, which is 24 litres a minute. But on this side we get flows of up to 34 litres a minute. And in fact with the alterations I've done today, possibly a little bit more. So the problem I had originally was I'd fitted a smaller pump on the original conversion. And what I didn't realise was there's about 30 or 40 metres equivalent length of pipework to both of the hot water cylinders upstairs. So the pump just wasn't man enough to deal with that. So I've changed it for a Magna 2580, and we're getting flow rate through the upper cylinder now of around about 14 litres a minute, which should be, I can drop about 14 kilowatts or so through the coil. And that would be at about delta T, probably about delta T 13, 14. So yeah, as you can see, pipe work everywhere. This was an aluminium heat exchanger boiler here before. Lasted about 3 years before the heat exchanger disintegrated, as the pH level in the system wasn't suitable for aluminium, and basically caused the collapse of the boiler, as it does in many aluminium heat exchanger boilers. Done quite a few of these, lots of Kestons, quite a few Worcesters, but the new boiler, Viessmann 200 stainless steel heat exchanger, no problems with that. That'll be there for that'll see my customer, I'm sure. We go into information here. At the moment we're in hot water mode, so we've got to see the light on the relay that I've wired in here. This is using a relay box off of Vitadens 100, which is in the back of the boiler here somewhere, so that when the stats on the cylinders operate, they're not really Viessmann compatible. They trip a relay which actually operates the Viessmann 100 relay in the back there, and that will give a false reading to the boiler. So if I have a little look at the, see if I can find it, domestic hot water, set to 55, information, actual domestic hot water. So the boiler thinks the water's 14 degrees. Once that's satisfied, it'll see 75. It'll never see any difference, either 14 or 75, which as far as the boiler is concerned is on or off. Whereas if it's plumbed in with a Viessmann cylinder using a cylinder sensor, which looks like the header sensor that I've applied here, it would actually see the true temperature of the water in the cylinder. Header sensor here is to give the boiler some idea of what the mixed circuit water temperature is. Otherwise it will only be working off the temperature of its actual own flow. And it needs to know what the flow is in the system. So a little header sensor strapped on there and give it some feedback. So Spira trap on the return, stop any muck coming back from the system. The system was very dirty with all the decayed muck in the system from the collapse of the aluminium heat exchanger boiler. Air vent here. When the boiler's fired up at high temperature during initial commissioning, this will vent off all the CO2. That will raise the pH to about 8.2, right into the correct range for copper and steel to protect them, and obviously out of the rate of aluminium. Well, not quite out of the rate of aluminium if you go by Elector, but for Worcester, be out of guarantee.